I want to talk a little bit about source transformation because you're going to see this in some of the classes that you take. And what source transformation is a way to simplify a circuit, not the parts you're looking at, but the rest of the circuit. And here's how it works. If I have a current source and a resistor in parallel, so this is current source I and resistor R. If it is convenient to do so, I can change that to a voltage source and a resistor in series, where the resistor has the same value as the resistor here, and the voltage source has the value of IR. Similarly, if I have a voltage source, and notice the voltage source has its positive terminal up and the current source was pointing up. If I have a voltage source and a resistor in series, if it is convenient to do so, I can redraw that as a current source and a resistor in parallel, where the resistor has the same value and the current is going to be V over R. Now, why can I do that? So again, I can't, if I'm supposed to be finding the current through this resistor, for instance, then I can't do a source transformation because I'd be transforming the thing I'm actually looking at. But let's say that I wanted to find the current through this resistor right here. Okay, so this is R1. Let's make it 10 ohms. Let's make this 5 ohms. And let's make this 2 volts. And I want to find the current to this 10 ohm resistor. Now I could do current division. Let's just do that to see what the answer would be. So current division would tell me that the current, so here's how you do current division. So if I have two resistors in parallel, here's R1, here's R2, and I have a current going this way, then the current, and then I'd say an I1 going down, and I2 going down, and now I'm remembering that y'all do this slightly differently than I do, gets the same result. I1 equals R2 over R1 plus R2 times I, the current coming in. The way I believe y'all do it is you say R1 over the equivalent resistance, which is product over sum, which is the same as saying R1 no, you do, how is it that you do it? You must do it the other way around. You must do the equivalent resistance product over sum over the resistor that you're going through, and you can see that that simplifies to the same thing, R2 over R1 plus R2 times I. Okay, so that is current division. So if I want to get the current through the 10 ohm resistor, I would take, oh, I said 2 volts, that would be 2 amps. That would be 2 amps times, so the current through the 10 ohm resistor would be 5 over 10 plus 5, R2 times 5 over 15, R2 times 1/3 or 2/3 amps. Okay, so now let's see what it is if I do a source transformation. So if I do a source transformation, then I get a voltage source of 10 volts, a resistance of 5 ohms. So the voltage source became 2 times 5, which is 10. And then I still have that 10 ohm resistor. So now, what is the current through the 10 ohm resistor? So in this circuit, my total resistance is 15. V equals IR. 10 equals I times 15. I equals 10/15, or I equals 2/3 amps. So I get the same answer. So what source transformation does is it allows me to, to change the part of the circuit that I'm not looking at, and it behaves the same way. Well, why does it behave the same way? Well, it behaves the same way because what's happening with this 10 volt current source and 5 ohm resistor is it produces the same effect as having the 2 amp current source and the 5 ohm resistor. The current through, if we didn't have this 10 ohm resistor, if this was all we had was the 10 volts and the 5 ohms, then our current would be 2 amps, just like we have here. And so they end up, acting the same way. Similarly, if I wanted to figure out, what is the voltage change across this, it's probably an easier way to see it. So if I look at this 2 amp current source and a 5 ohm resistor, what is the voltage difference across this resistor if all I had was this 2 amp current source? Well, I'd have 2 amps going this way, and so my voltage change across this resistor would be 10 volts. So it'd be like having 10 volts here and 0 volts here, or like having a 10 volt voltage source. And so they act the same way. You can't, and like I said, you could not use this to find the current through the 5 ohm resistor, but it doesn't affect the rest of the circuit. So when do you use source transformation? Well, let's say I had something like this. And I needed to find, let's just make this 2 amps, 1 ohm, 4 ohms, 2 ohms, and let's say that I needed to find the voltage right here. So this resistor, the 1 ohm resistor and the 4 ohm resistor, are not in series or in parallel. But if I do a source transformation, and I get this voltage just by multiplying these together, 2 times 1, and then this resistor will now be in series. And I have a 4 ohm resistor. So now I've got this 1 ohm and 4 ohm resistor, I can combine those into a 5 ohm resistor. And now, if I do another source transformation and take this back to a current source, then this becomes 2/5 amps and 5 ohms, so it becomes a current source and a resistor in parallel. And that was 2 ohms. And now my 2 resistors are in parallel, and so I can combine them as product over sum. So 10/7. And then I can now do a source transformation back if I want to. You get 20/35. And 10/7. And then depending on the other information that I had, now I've got a circuit that I can look at. I can't in order to actually find the voltage there, I would need to know at what point I was in charging or discharging the capacitor. But that just kind of gives you an idea as how I can simplify this original circuit when the resistors were not in parallel or in series. So just to sum up, source transformation, so let's say I had 2 milliamps and 2 kiloohms, so that's 0.002 amps times 2000 ohms gives me 4 volts. So 4 volts and a 2 kilo ohm resistor. So that's how I would change that.